Hi guys, design time again. This time, small project, a small design, but a very practical design, at least for me. A couple of years ago, I purchased from a distributor a whole bunch of these displays. They are from Electronic Assembly, EA, and it's a dog series, like the Woof Woof. They have an onboard COG controller, chip on glass. It's the ST736, and it can be used in 4 or 8 bits parallel, or with SPI, serial peripheral interface, a 4-wire one. The good thing is that this controller is compatible with the venerable HD44780, the KS006U, and the ST706xx. All of these are just character controllers, quite old character controllers, that we controlled in parallel 4 or 8 bits. I'm using this kind of this kind of controllers, this kind of displays, like the 1602 and 1604 for 4 lines, 1602 is 2 lines, or 2002 for 20 characters, 2 lines, etc. All of these have the same HD 44780 controller inside. They are very popular. I use them in many of my devices. Ooh, that's dirty. Anyway, and I use an I2C to parallel converter. It's just a shift register, more or less, or an extender, a port extender. And in Arduino, then there is an I2C liquid crystal library for that. And so you can, with this adapter, with this converter, you can use these things as on I2C. They're fast enough, for at least for everything I did till now. You saw that on my previous one of my previous videos with a digital dip meter, the DigiDip. So, and this 16 pins header is quite standard for these displays, and I wanted to have these displays on this pin header. So, and this is what came out. I will explain you what I'm doing here a little bit later. I just want to show you how these displays, these EA displays, by the way, the ones I have are the DOGM16xx in green, a green backlight. These displays, I cannot look, these displays have a dedicated backlight. It consists of 2 parts. The backlight part, that can be whatever color you want or that's available. They have 2 LEDs that can be either put in series or in parallel. And this is the LCD itself. Mine consists of 3 lines of 16 characters. And yeah, has all these driving capabilities that I showed you before. So let's have a little deeper look on the datasheet. So that's the datasheet. Here you can see how they look, a little bit nicer in color. You see that, let me zoom that a little bit. That was not good. They consist of the backlight here and the display itself. you have these configurations, 1x8, 2x16, or 3x16, and these are the ones I have. They have quite a lot of backlight colors available. And the good thing is, this is how they look. They were very cheap. This is why I bought it, because normally these displays are quite expensive. Here you see again the displays itself with the backgrounds. And here it says application examples, but these are the possibilities you have how to connect them. 8-bit 3.3 and 5 volt, 4-bit 3.3 and 5 volt, SPI serial 3.3 and 5 volt. All these connections are possible with the adapter that I designed, and I will show you in a jiffy. Just a little bit more information. And here you see how these are the possibilities of the backlight, the two pairs of LEDs. You can put them either in parallel, lower voltage, more current, or in series, higher voltage, lower current. Yeah, and this is the RGB ones. So, let me show you what I designed. And this is what came out. You can compare it with this one. Both of them have these 16 pins, completely compatible to this one. The only difference is that you cannot change the contrast. There is no contrast pin for these ones. But you have here, from 1 to 16, all the connections that are used here too. Additionally, optional, 2 other connections that can be used when it's used in SPI mode, in serial mode. So, grab a seat and look what's here. There is a lot of stuff. All these configurations on the design, on the datasheet that you saw, all the possible connections or the driving connections are broken out or fanned out here with jumpers and eventually with capacitors needed or not. The default, what you see here is 4-bit. The backlight leads are serial, and that's it. This is the compatibility to this one, 4-bit and backlight. With that, I can connect it again to the I2C to parallel converter and use it either on a breadboard or exactly where I would use these ones. But additionally, you can use them as SPI too if you want. I will show you now how this thing looks when it's working on a breadboard. By the way, this is the controller that is as a chip on glass, directly on the glass, COG. It's a normal dot matrix LCD controller driver, and as you see here, it's completely compatible to these other types. There's only SPI, unfortunately. On the DOG series, EA DOG series, they do not use the I2C interface that this one, because they have only this controller and not the I controller for I2C. Okay, let's look how it works. Okay, this is a little breadboard I'm using for small projects to test or ideas to test. And here you see how this thing is already working. just a demo with a histogram, with a parallel, with a bar graph, vertical bar graph. Yeah, for the parallel usage or I2C usage, more or less I2C usage of these displays, or even better said, my converter here, converter board, I converted a dedicated an existing I2C liquid crystal display library with the code that is needed for driving my board here. It's called DOGM liquid crystal display something, and it can completely be used in the Arduino environment to drive this board with all the functions that the old library had, including the horizontal and vertical bar graphs and histograms, etc. Okay, to be honest, this is all for today. If you like my videos, if you like my designs, if you like what you see, push the like button, consider to subscribe at my channel, and ring the bell, push the bell button, so you can get notification when I put new videos online. All these things helps my channel to grow and to give you more informations and more content. Design files, if somebody wants them, are available on request. Okay guys, that's all for today. It looks funny, huh? Have a nice day. Cheers and thank you for watching. Bye.